Notes. Our next topic is finding the inverse of a function. So, quick review of solving a function. So I want to tell me the steps to solve this. No idea. All right, before we go there, let's tell me the story. Okay. What's happening to x? What's happening to x? It's being what? What's happening right here? What operation is that? I hear it. Multiplication is being multiplied by 7. Then what's happening? What else is happening to x? After it's being multiplied by 7, then what's happening? Add it to 2. So this is called the story of x. I do this, I don't know if you ever heard of this, right? I used to do this a lot in my Algebra 1 class. I do this so that you can understand what's happening in x in order for you to solve for x. So, when I go to solve, here are my steps. This is 1, this is 2. When I go to solve, I reverse the steps. I do my story the opposite. So, I do step 2, then step 1, but I do the opposite. So instead of add, I'm going to what? Subtract. My inverse operation of addition is subtract. So I'm going to subtract by 2. And then instead of multiply, what's my inverse operation? Divide. So, writing these steps out is going to help you when there are problems with a lot of multiple steps. So if I wanted to solve, now I know what to solve. I'm going to subtract 2, and I'll get 21 equals 7x. And then I'm going to divide by 7. Right? Everybody remember those steps? That's how you solve an equation or solve a function. Similar to what you do in your inverse, except before you start your inverse, step 1 is going to be to switch your x and your y. Step 1 is going to be to switch your x and your y. And then you're going to solve like you normally solve. So, instead of 23, if we had y, I'm going to show you as a function. Okay? And hopefully you remember, so this is a function. In order to find its inverse, you have to write it as an equation. And then you switch your x and y. And now you solve for y. Did everybody write this part down? Anybody need to copy this still? And so very often you are used to solving for x. However, in algebra 2, x is not going to be our only variable. So if you ever get stuck, you write the story of whatever you're solving for. So let's write the story of y. What's happening to y? Very similar to what just happened to x. So what's happening to y right now? What's happening to y? It got switched, and then what? What's happening right here? It's being multiplied to 7. Then what's happening? It's going to be added by 2. So the same thing that happened to x before. So to solve, we just do the opposite. Right? So we're going to subtract 2. However, you can't subtract 2 from x. So you just write x minus 2. Alright? And lastly, you divide by 7. However, you cannot divide an expression by 7, so you just simply rewrite it. However, this is an equation. What do we want? What are we doing? Inverse what? Functions. So what do I need to change in order for this to be a function? That y has to become a what? F of x, not just f, right? However, f of x is already this function. So f of x can't be that function, right? Nope. So inverse functions are written with a little negative 1 up top. Don't ask me why. You don't want to know right now. And then I just write my inverse function. Questions? Yeah.
Use the tape.
Yeah.
That looks fun.
Yep, fun. They're so excited. Okay, find the inverse. Oh, what time is it? So, if you write the story out, what also can happen with writing the steps out is you can do them in one step now. Because I'm saying I need to subtract 12 and divide by 2. So I'm going to rewrite that so you can watch me do it. So I know that I have to take my x, and I have to subtract 12, and I have to divide by 2. You don't have to do it in multiple steps because you already wrote it out. However, in order for you to do this, you need to make sure you write it out. This can also be broken up so that you can actually divide that 2 by 12 of x divided by 2 minus 6. And then you change that y to function operation. And now this is my inverse function. Questions? No questions? We're going to do some understanding of inverses. So, function f doubles the input, then subtracts 8. Function g adds 8 to the input, and then divides by 2. So, function f doubles the input. What's the input of function f? What's the input of that function? Yes. X. This is the input. Okay? So we're going to use the X. This is the input. So, doubles the input. What does that look like? Nope. Doubles the input. What does doubles mean? 2, you said? What would 2 though? Times 2. So what does X times 2 look like? 2x. So, x squared is being multiplied by itself. That's x times x. Double x means 2x. Then subtracts 8. What does that look like? So, this is our function of f. Now we have a function of g. Function of g adds 8 to the input. What does that look like? Adds 8 to the input. What does that look like? Adds 8 to the input. 8x? 8x means 8 times x. Positive 8. Just a positive 8 means there's no input. Adds 8 to the input. What's the input? What's the input? X. So what does it look like to add 8 to the input? X plus 8. If my input is x, to add 8 to it means to add 8 plus 8. Then divides by 2. What does that look like? Divided by 2. Okay? And to simplify this, okay. So here's our 2 equations. We're going to find f of 10. And then we're going to find g of f of 10. So find f of 10 first. What's f of 10? You said 20? How'd you get that? Say it. How'd you get that? 2 times 10, but then you have to? Yep. So you get 12. Right? So f of 10 is 12. So then if I take g of f of 10, that's the same thing as taking g of what? What's f of 10? 12. So g of 12 would be g would equal 12 divided by 2 plus 4. Huh? So g of f of 10 is equal to 10. So now find f of 0 and g of f of 0.